Hello. Today we're starting Chapter 16. This is mobile networking. This is not Wi-Fi. We cover Wi-Fi in Chapter 14. We'll start off with our cellular WAN technologies, cellular wide area networks. There are four technologies we have to be concerned with for this exam, or this test. GSM and Edge, CDMA, HSPA+, and LTE. The Global System for Mobile Communications, or GSM. This uses a time division multiplexing to allow users to share bandwidth. GSM was the first technology where we actually had the subscriber identity module card, or the SIM card. It's a 2G network. The final version increased data rates for GSM, and that was called Edge, or the enhanced data rates for GSM evolution, and that supported bandwidths up to 384 kilobits. It's why it was the most popular cell phone communication technology outside of the U.S. Within the U.S., only AT&T and T-Mobile use this technology. Code Division Multiple Access, or CDMA, was also a 2G network. It did not use SIM cards. It uses spread spectrum to allow users to share bandwidth. So basically each cell phone received a slightly different frequency for transmitting and receiving data. And again, this was widely adopted here in the United States, but outside the United States it wasn't used very much. High-speed packet access, or HPSA+, this is the first 3G technology. It was developed by the International Telecommunications Union, or the ITU, and it developed to be known as the International Mobile Telecommunications 2000, or the IMT 2000. It supported higher data speeds, up to 10 megabits, full-time internet connections, and here's where we started a lot of multimedia within text messaging. So you can basically send pictures within text. Long-term evolution, or LTE, is our 4G technology. It was developed about 10 years ago in 2010, and it supports up to 300 megabits of data download and 75 megabits of data upload. All LTE systems use SIM cards, and there is support for LTE for NICs and USB devices. So you can actually, if you want to add a workstation or laptop that doesn't have LTE built in, you can actually go out and buy a NIC or a USB device. Bluetooth was developed to simplify connection between devices. It supports connections between PCs, tablets, phones, to headsets, keyboards, and mice. It's relatively simple to configure. You basically bring the two Bluetooth devices together, and you can pair each other up, and they connect, and you're good to go. When you have a Bluetooth network in that scenario, it's called a Personal Area Network, or PAN. Early Bluetooth did not have any security built into it. Several years ago, two security items were added to Bluetooth. The first security feature basically turns Bluetooth off, so it's not discoverable. So they're not visible unless you set the device to discovery or discoverable mode. When it's turned on, the Bluetooth device is visible for about 2 minutes, and then it's automatically turned off. Now, there are two older Bluetooth attacks that you should be aware of. One is called bluejacking. Bluejacking is not really something that was used to steal data. Bluejacking was simply used to send messages to phones. So, as you're walking down say a mall or near a store, there could be some technology within the store that would detect your Bluetooth phone and would send you a message, about some great sale that they were having. Again, it wasn't really a security breach. It was really just more of an annoyance because you had these potential for ads to come at you, and you just didn't really want them. Now, blue starfing was actually used to steal data from the Bluetooth device. So keep in mind, those are the two attacks you have to be aware of. We'll stop these. The discovery mode, if you're not advertising, bluejacking can't see you. and the pin will stop blue snarfing, really, from even attempting to actually pair to your device. In Bluetooth version 4, data is encrypted between devices. So with other mobile technologies we have, these are used for various things from payments to inventory. The first one we'll talk about is near field communications, or NFC. This is used in credit cards, Apple Pay and Android Pay. It's low speed. It's designed for very short range, so less than 5 centimeters. You pretty much have to be right on top of the device to see it. It uses 13.56 megahertz, and this is used primarily by credit cards or, again, Android Pay and Apple Pay. It does contain some basic encryption, but this is not the best encryption in the market, so just be aware of that. Radio frequency identification. There are a lot of standards in this. It's used for a lot of different things. It's so many applications. There's a lot of diverse frequencies. There's not a single standard. The frequencies run from 120 kilohertz to 10 gigahertz. A lot of different applications. Get it fairly close, about within a meter or two, for this to work. There's either very weak or no encryption, and it's commonly used with labels. The RFID tag can be placed on a pallet, so when a store comes and a pallet reaches a store, they can scan the RFID tag, and then the RFID tag is then referenced to some kind of a database, some kind of application that tells you what's on that pallet. A lot of different uses in this. Pets. The tracking of pets, the RFID tag that's inserted in a pet, you can inject it into your pet, so if they're lost, a vet can scan it, or an animal shelter can scan it and reunite you and your pet. That's all done with RFID. Infrared, this is basically used for remote control for TVs and other devices, old DVD players, that type of thing. Adaptive Network Technologies, ANT+. Again, this is another low speed, low power, very similar to NFC. This is used by devices that don't send a lot of data, and they go for long periods of time without transferring data. Heart rate monitors are one of the ones, something like, again, not a lot of data, and it's only used when you're maybe visiting your doctor's office. This is not supported by Apple. ANT+ does have AES encryption. Z-Wave and Zigbee, these are two technologies that are used in home automation. Z-Wave is a proprietary standard with an open API. Zigbee is an open standard. They create a mesh technology within the network, and they do use a hub to actually connect to your Wi-Fi network or to a wired network. BYOD, or Bring Your Own Device, is more of a process using for personal technology. This BYOD allows an employee to take their own personal computing device, whether it be a phone, a tablet, or a PC, and use that in their office connected to your work network, where that personal device is given access to data, applications, and other, and the corporate network. This does require tight controls and a separation of personal data from corporate data. Onboarding is the process of introducing a new network device to the corporate network. This can apply to both corporate devices and personal devices. How do you introduce the device to your network? How is it authenticated? How does it access the network? Is it allowed in the wireless network, the Wi-Fi, the wired network? If it's what VLAN does it belong to, etc. Basically, how do you get this device onto your network, and what rights does it have? The offboarding process is a process of removing a device from the network. When we take a device off the network, we want to make sure data is removed from the device, any corporate data is moved from the device. We want to make sure applications are removed and authentication of the device is actually removed. When this device is removed, we don't want someone to come in, go to buy this device, come back into our network, and have access to our network. Geofencing is a technology where we use geographic constraints on devices and use that to determine if they can access data. So a phone will have a GPS device, or a tablet may have a GPS device built into it as it works its way around an area. If it's within a certain, let's say you're working for a local government, if you're within that city limit, the device works. When you leave the city limits, access is removed. What happens when you lose a mobile device? So you've got a lost device. Make sure that device is reported to the appropriate person in the department. It may not be IT. Might be a physical security department, or some other process, some other department. Locate or attempt to locate the device using software that might be built into the device, like Find My iPhone. Remote wipe the device. Disable network access by disallowing certificates, removing signatures, changing passwords, whatever it needs to do to remove that device from the network so they can't log back into your network with it. Disable accounts or change the authentication method. So we'll say someone loses a cell phone, that cell phone has access to corporate email. You want to remove that corporate access. And then of course you want to reissue a new device. The Internet of Things is what we currently call you're adding devices onto your network that may not have a direct human interaction, but they control various things, aspects of your environment. For example, a thermostat. That could be an IoT device. A time clock that's on your network that someone badges in, the badge is sent to a central database. Any number of things, video cameras, etc. They're all IoT devices. They have their own software, their own firmware, but they don't really have people using them on a daily basis directly. So you need to find a way of hardening these devices, making them more impervious to network hacks. One thing we can do on these and have a lot of bang for the buck is to update firmware and software on a regular basis. We can use security precautions, making sure that these things are locked down physically to where they are, so they can't just be removed from a wall and walked off with. And apply any security options that can be built in with the system. Network authentication, encryption. Make sure that the devices are hardened as much as possible to prevent people from hacking into them and taking control. That's it for this chapter. So we'll come back and get the next chapter is virtualization and cloud computing.